Mark P. Otten back with you.
Okay, this is your video for a ANOVA with two independent variables, both of which are dependent samples, independent variables. So if you watched my primary video here on two-way ANOVA and SPSS, you're probably a little bit tired, so I'll try to keep this quick. All right, so I'm showing you the setup here in SPSS, and then the display over to the right is the means that I've just laid out for you in Excel to kind of match up and show you what's going on with this particular data set. So this is an extension of the other video talking about students doing jumping jacks in front of a female experimenter versus doing jumping jacks in front of a male experimenter. So here we have made believe that these poor participants have been asked to come in twice. So there's a time 1, time 2, and then the experimenter gender remains as the other independent variable. So at time, let's see. So for person number 1, let me highlight them in the SPSS file here. Person number 1 comes in, does 0 jumping jacks in front of the female experimenter at time 1, let's say on the first day. Then later that same day comes back and still does 0 jumping jacks in front of the female experimenter. So 2 rounds with the same experimenter, time 1, time 2. Then there's another round with a male experimenter, and this particular participant still does 0 jumping jacks each time, so refuses to do any. Second participant here does 0 jumping jacks in front of the female experimenter, then does 2 in front of the female experimenter at time 2, and then proceeds to do 0 in front of the male experimenter at time 1, and the same thing at time 2, and so on. So looks like the third participant there is the only one really doing very many jumping jacks. So if we go over to the summary here, if you take a mean, let's start with the mean in the top left here. This is for the female experimenter at time 1. The mean is 5. That's just the mean of these 3 values in SPSS, so 15, 0, and 0. 15 divided by 3. The 3.33 here, this mean is for the male experimenter at time 1. That's this one, that's like 10, 0, and 0, so 10 divided by 3. So that's how we're getting means out of these categories, out of this data. And we end up with a table that looks like this for the 4 means. Of course, the male experimenter inspired 0 jumping jacks at time 2. He was probably bored. All right, so then you've got your marginal means out on the side that can tell you something about the main effects that might exist or might not exist here. On column 1 versus column 2 comparison, you've got 4.835 for a female experimenter, which is greater than 1.665 for the male experimenter, suggesting that we might have a main effect such that participants are doing more jumping jacks in front of the female, it appears. We'll see in a minute with SPSS whether that is a significant main effect or if it's just a main effect in appearance. Then if we go to the row 1, row 2 comparison here, we've got 4.165 for time 1, 2.335 for time 2. So it looks like participants are doing more jumping jacks at time 1, perhaps because they're less tired, we could say. And so there's a difference between those 2 numbers as well, suggesting that there appears to be a main effect there as well. Of course, to get these marginal means, we're just averaging across rows and down columns. So for example, this 4.835 is the mean of 5 and 4.67. And going across, for example, we have 4.165 here, which was the mean of 5 and 3.33. Okay, so those are your marginal means, which give you an idea of what to expect for the main effect results here. Then I've got these differences. These are sometimes called simple effects. I don't know if they're actually simple, but the 0.33 is 5 minus 4.67, which tells you that when the experimenter is female, folks are doing slightly more jumping jacks at time 1, 5, compared to 4.67 at time 2. For the male experimenter, it's 3.33 minus 0, giving you 3.33 for your difference there. So if you compare those 2 differences, 3.33 is greater than 0.33. Therefore, there might be an interaction here such that there's a bigger difference between time 1 and time 2 for the male experimenter than there is for the female experimenter. But again, we got to go to SPSS to figure out if this is a significant interaction or not. So let's do that. I'm going to run you through the SPSS here for just these 3 people in this dependent samples situation. So dependent samples translates in SPSS to repeated measures. So you're going to go analyze general linear model, repeated measures, and then you're going to declare 2 factors here, 2 within subjects factors. So dependent samples means within subjects, same thing. So the first one is going to be time with 2 levels, and it's going to be 2 time points. So you put time with 2, you click add, then you go to the other one, which in this case we could call experimenter gender. I'm just going to put exp gender with 2 levels as well. It's going to be male and female. You got to remember to hit add on both of these so they both appear down here in this box below. And then you're going to hit define. And here's where you got to keep it straight. You look at the top here, within subjects variables, time, comma, exp gender. So we're going to start moving these over, and we just got to keep an eye out for the order here. So time 1 goes first for experimenter female. Then we got to go time 1 for experimenter male. Then we got to go time 2 for experimenter female. And then you got to go time 2 for experimenter male. And the reason I put them in that order is because of this guide here, this little statement at the top with time, comma, exp gender. That means that when you go into the list, 1, comma 1 means time 1 female, 1, comma 2 means time 1 male, 2, comma 1 time 2 female, and so on. The last one, time 2 male. So just got to keep that in order and you'll be all right. If you are doing this problem and you get stuck on this step where you're not sure if they're in the right order, just go ahead and give up and forget about it. No, just go ahead and reach out to me or one of the TAs. Okay, the other thing I'm just going to add is options and descriptive statistics, and then continue. So I just hit options, descriptive statistics. That'll give us the means that we just got over there in Excel over on the right side. So let's compare and see how it comes out. Crossing my fingers that everything came out right. Okay, so what we've got here is a little bit of extra stuff at the top. And so I'm going to scroll down to tests of within subjects effects. In this case, your p-values that you need are going to be in here, among other information. So let's take a look and let's contrast. Well, first of all, did we get the means right? Let's look at the descriptive statistics at the top. We've got 5, 3.33. Yeah, it looks like if you go down the column of means here, the 5 corresponds to time 1 female, the 3.33 corresponds to time 1 male. So you can double check yourself by this descriptive statistics box, which I initially skipped over. Okay, now I need to go back down where I was going before and look at tests of within subjects effects, like I said. For time, the main effect of time, you look just across this top row, it's labeled time and a p-value of 0.517, so no, there is no significant main effect of time because 0.517 is greater than 0.05. Then you go down to exp gender. For experimenter gender, you go across that top row, you get 0.359, so no, there is no main effect of experimenter gender, 0.359 greater than 0.05. And then for the interaction, 0.286 here, time star exp gender is the row, and we have 2.286, so 0.286 greater than 0.05. Again, no significant interaction. So it's a dud. Nothing happened here that was significant, but the reason is, well, we only had 3 people in our sample, so we typically need a lot more than that if we're going to see significant results pop up. Even though it appeared that there were effects, they aren't significant by this analysis. And that's it. Just reach out along the way if you get stuck at certain steps and whatnot. Good luck. Enjoy.